Welcome to Part 8 of the Android Interview Series 2024, where we dive deep into Android architecture. This episode is crafted for developers preparing for interviews or seeking a solid understanding of architectural patterns in Android. We'll explore the evolution of Android architecture, compare popular patterns, and discuss their practical implications. Whether you're a beginner or an experienced developer, this guide will help clarify concepts and provide actionable insights for building robust Android apps. Let's start by setting the stage for why architecture matters in Android development and how it shapes the maintainability and scalability of your projects. Before we delve into architectural patterns, let's briefly review the structure of this interview series. Part 1 covers Android basics, Part 2 focuses on expert-level topics, Parts 3 and 4 introduce Java and Kotlin basics, while Parts 5 and 6 explore Kotlin coroutines and flows. Part 7 discusses Jetpack Compose, and now, Part 8 centers on Android architecture and framework. This progression ensures a comprehensive understanding, building from foundational concepts to advanced architectural strategies. By following this series, you'll gain a holistic perspective on Android development, preparing you for both technical interviews and real-world challenges. Start with the classic MVC, Model View Controller, and MVP Model View Presenter patterns. MVC separates data, UI, and business logic, but in Android, the controller is tightly coupled with Android APIs, making unit testing difficult. Modularity suffers because changes in the view often require changes in the controller, leading to maintenance challenges. MVP improves testability by introducing a presenter that handles business logic and updates the view. The view displays UI and the model manages data. However, MVP doesn't inherently handle lifecycle events, so extra code is needed for configuration changes. Both patterns have limitations in Android, prompting the shift to more modern architectures. VVM, Model-View-ViewModel, is widely adopted in Android development. The view model is a lifecycle-aware component that holds and processes data for the UI, separating it from the view. The model represents the data layer and interacts with the view model, which updates the view using LiveData, DataBinding, or StateFlow. This architecture allows the view to observe changes and update UI reactively, minimizing memory leaks and configuration issues. MVVM's separation of concerns makes code more modular, organized, and easier to maintain, while its lifecycle awareness ensures data retention across configuration changes. VVM offers several advantages for Android development. It encourages a clear separation between UI, business logic, and data, resulting in a modular and maintainable codebase. The view model retains data across configuration changes, reducing memory leaks and simplifying UI data management. Decoupling business logic from the UI framework makes unit testing easier, improving code quality and reliability. MVVM enables a reactive approach where the view automatically updates in response to data changes, creating a responsive and dynamic UI. These strengths make MVVM a preferred choice for modern Android apps. Despite its strengths, MVVM has some drawbacks. It requires a deeper understanding of reactive programming and lifecycle management, which can be challenging for newcomers. Extensive use of data binding can reduce code but may introduce boilerplate and make debugging more complex. Errors in data binding are not always immediately apparent, complicating troubleshooting. Developers must invest time in learning these concepts to fully leverage MVVM's benefit. Balancing simplicity and advanced features is key to avoiding pitfalls and maintaining code quality. Common issue in MVVM is the fat view model problem, where too much logic is placed in the view model as the app grows. This leads to complex, hard-to-maintain code. To address this, developers use the repository pattern to abstract data access, delegate business logic to use cases or interactors, and utilize separate state management classes. Event wrappers handle one-time events, simplifying UI event handling. These strategies keep the view model focused on UI state and interactions, enhancing maintainability and testability. Repository pattern is a design pattern used to abstract and centralize data access logic. It acts as a bridge between the domain layer business logic and the data layer data sources like databases and APIs. By isolating data handling, the repository pattern keeps the UI and domain layers focused on their roles, improves testability, and centralizes data management and caching. This abstraction makes the codebase easier to maintain, test, and scale, supporting complex data operations without exposing implementation details. Design a repository that interacts with both a local database and a remote API. Define the repository interface in the domain layer. The implementation in the data layer fetches data from the API and caches it locally. If the API call fails, it retrieves data from the local database. This approach allows the rest of the app to call methods like getProducts, without knowing or managing data retrieval or caching strategies. The repository pattern ensures separation of concerns and simplifies data management. MVI Model View Intent is inspired by functional and reactive programming principles. The model represents the application's state and data, holding all information needed to render the UI. The view renders the UI based on the model's state, remaining entirely reactive and free of logic. Intents represent user actions or events, dispatched from the view to the model, which processes them and updates the state. MVI promotes a unidirectional data flow, ensuring predictable state changes and easy testing. VI's key principles include unidirectional data flow, a single source of truth for UI state, and immutable states. Intents are sent from the view to the model, which processes them and returns a new state. The state is managed in one central location, making testing and debugging easier. Each state change creates a new state, preventing unintended side effects and making transitions easy to trace. These principles help prevent unpredictable state changes and race conditions, supporting robust UI management. Pack Compose aligns well with MVI principles. Its declarative nature simplifies user interaction handling and keeps the UI in sync with application state. In MVI, UI state is managed by the view model using StateFlow or LiveData, ensuring immutability and predictable updates. Composables observe the state and recompose automatically when it changes. User interactions are captured as events intents and sent to the view model, which adjusts the state accordingly. Effects handle one-time actions like showing a snack bar or navigation managed via channels. Lean architecture provides a structured way to organize code into layers, each with its own responsibilities and dependencies. This approach makes applications more maintainable, flexible, and testable. Typically, clean architecture consists of 4 layers: presentation layer, domain layer, data layer, and framework UI layer. Each layer is designed to minimize dependencies and maximize separation of concerns, supporting scalable and robust Android application. Presentation layer is responsible for the UI and communication between the user and the app. It handles user input, presents data, and manages UI state. Examples include activities, fragments, and composables. This layer interacts with the domain layer to execute business logic and update the UI. By keeping presentation logic separate, developers can focus on delivering a responsive and intuitive user experience. Domain layer contains the business logic and use cases, or interactors of the application. It executes business rules without directly interacting with data sources or the UI. This layer is agnostic to platform or framework, making it suitable for pure unit testing. Examples include repositories, entities, and use cases. By isolating business logic, the domain layer ensures that core functionality remains consistent and testable across different platforms. Data layer manages data sources and implements the repository pattern. It provides data to the domain layer by implementing repository interfaces defined in the domain. Examples include retrofit for network requests, room for local databases, and paging sources. The data layer abstracts data access, ensuring that the domain layer doesn't need to know where the data comes from. This separation supports maintainability and scalability. Framework and UI layer houses platform-specific elements and external frameworks that your application depends on. This includes Android SDK components, dependency injection frameworks like Dagger or Hilt, and navigation components. By isolating these dependencies, clean architecture ensures that core business logic and data handling remain unaffected by platform changes, supporting long-term maintainability. Communication between layers in clean architecture is carefully managed. The presentation layer interacts with the domain layer using use cases, often implemented as suspend functions or returning flow live data for asynchronous operations. The domain layer interacts with the data layer through repository interfaces, while the data layer manages communication between various data sources. This structured communication ensures clear separation of concerns and supports scalable application design. Data flows from the data layer back to the domain and presentation layers using flows, live data, or suspend functions. The presentation layer observes or collects this data to update the UI. The data layer may have separate data sources for network requests, local database interactions, and cache, all abstracted within the repository. This centralized management simplifies data operations and supports efficient caching strategy. Repository pattern offers several benefits, including abstraction of data access, separation of concerns, improved testability, and centralized data management. By hiding the details of data sources, the repository pattern allows the UI and domain layers to focus on their specific roles. Mocking the repository for unit tests becomes easier, and complex data operations can be implemented and maintained efficiently. Implementing a repository involves defining an interface in the domain layer and providing an implementation in the data layer. The implementation fetches data from an API and caches it locally. If the API call fails, it retrieves data from the local database. This approach allows the rest of the app to call methods without managing data retrieval or caching strategies, supporting separation of concerns and maintainability. Lean architecture supports unit testing by isolating business logic in the domain layer and abstracting data access through repositories. Mocking repositories and use cases becomes straightforward, enabling developers to test core functionality without relying on platform-specific components. This focus on testability ensures that applications remain reliable and maintainable as they evolve. By organizing code into distinct layers and abstracting dependencies, clean architecture enhances scalability and maintainability. Each layer can evolve independently, minimizing the impact of changes on other parts of the application. This modularity supports large-scale projects and simplifies onboarding for new developers, ensuring long-term success. Reactive programming is a core concept in modern Android architectures like MVVM and MVI. It enables automatic UI updates in response to data changes, supporting responsive and dynamic interfaces. Tools like LiveData, Flow, and StateFlow facilitate reactive data handling, allowing developers to build applications that react seamlessly to user interactions and state changes. Lifecycle awareness is crucial for managing UI data and preventing memory leaks in Android apps. Components like ViewModel retain data across configuration changes, ensuring that UI state is preserved during events like screen rotations. This lifecycle management simplifies data handling and supports robust application design. Effective state management is essential for handling complex UI-related data. Separate state management classes can centralize the handling of UI states, reducing clutter in the view model. Event wrappers manage one-time events, making UI event handling more predictable and simplifying responsibilities within the view model. Use cases or interactors encapsulate specific pieces of business logic, moving responsibilities out of the view model. Each use case handles a single action, keeping the view model focused on UI state and interactions. This approach enhances testability and reusability, supporting clean and maintainable code. Event wrappers, such as single live event or custom event classes, handle events that should only be consumed once, like navigation triggers or toast messages. By using event wrappers, developers simplify the view model's responsibilities and make UI event handling more predictable, supporting clean architecture principles. Unidirectional data flow is a core principle in MVI and modern Android architectures. Intents are sent from the view to the model, which processes them and returns a new state. This clear flow prevents unpredictable state changes and race conditions, supporting robust and maintainable UI management. Mutable states are encouraged in MVI, meaning each change creates a new state rather than modifying the existing one. This immutability helps prevent unintended side effects and makes state transitions easy to trace. Managing state in one central location supports easy testing, debugging, and persistence. Jetpack Compose's declarative UI model aligns perfectly with MVI principles. Composables observe state and recompose automatically, ensuring the UI stays in sync with application state. This reduces complexity in handling user interactions and supports predictable UI updates, making Compose a strong fit for MVI-based architectures. Effects in MVI handle one-time actions like showing a snack bar or navigation. These are managed using channels, allowing the view model to dispatch effects without affecting the app's overall state. This separation ensures that transient events are handled predictably and do not interfere with state management. In practice, the repository pattern allows developers to centralize data management and caching. By abstracting data access, the repository can decide whether to fetch data from a remote API, local database, or cache. This flexibility supports efficient data operations and simplifies maintenance as the application grows. The domain layer interacts with the data layer through repository interfaces. The domain layer doesn't know where the data comes from, it simply calls the repository interface, which the data layer implements. This abstraction supports separation of concerns and makes the application more flexible and testable. Within the data layer, the repository manages communication between various data sources, such as remote APIs, local databases, and cache. Data sources are abstracted within the repository, which decides the source and manages caching logic if necessary. This centralized management supports efficient data handling and robust application design. Communication from the presentation layer to the domain layer happens using use cases. Use cases are often suspend functions or return flow live data to support asynchronous operations. The presentation layer collects the data or subscribes to updates and updates the UI accordingly, supporting responsive and dynamic interfaces. Data layer exposes data as flows, live data, or suspend functions that the domain layer or presentation layer can observe or collect. This supports reactive programming and ensures that UI updates happen automatically in response to data changes, enhancing user experience and application reliability. Testing repositories is straightforward in clean architecture. By mocking repository implementations, developers can test business logic in the domain layer without relying on actual data sources. This supports reliable unit testing and ensures that core functionality remains consistent as the application evolves. Clean architecture scales well for large projects. By organizing code into layers and abstracting dependencies, each layer can evolve independently. This modularity supports team collaboration, simplifies onboarding, and ensures that the application remains maintainable as it grows. Understanding Android architecture is crucial for interview success. Focus on core concepts like MVVM, MVI, clean architecture, and the repository pattern. Practice explaining the advantages and disadvantages of each pattern, and be ready to discuss how you would implement them in real-world scenarios. Reviewing these concepts will help you confidently answer interview questions and demonstrate your expertise. Applying architectural patterns in real-world projects involves balancing simplicity and complexity. Choose the pattern that best fits your application's needs, considering factors like scalability, maintainability, and testability. Use repositories, state management, and lifecycle-aware components to build robust and responsive Android apps. The Android developer community offers a wealth of resources for learning and mastering architectural patterns. Follow experts, read articles, and participate in discussions to stay updated on best practices and emerging trends. Leveraging community knowledge can accelerate your learning and help you solve challenging problems. Explore recommended articles and cheat sheets from Android professionals and Google developer experts. These resources provide practical tips, common pitfalls, and advanced techniques for mastering Android architecture. Continuous learning is key to staying ahead in the fast-evolving Android ecosystem. Visual aids such as diagrams and flowcharts can help clarify architectural concepts. Use visuals to map out data flow, layer responsibilities, and communication patterns. This approach supports understanding and collaboration, making it easier to explain and implement architectural patterns in your projects. Summary: mastering Android architecture is essential for building scalable, maintainable, and testable applications. By understanding patterns like MVVM, MVI, clean architecture, and the repository pattern, you can design robust apps and excel in interviews. Continue exploring resources, practicing implementation, and engaging with the developer community to deepen your expertise. Happy coding!